Go live on YouTube as well. So I'm pressing the button. Armando GM, welcome, welcome. Let's see. Okay, I think we are good to go on the YouTube as well. So hi folks on YouTube, hi Zoom, hi everybody, GM. Um, we'll wait for a couple of maybe 1 minute until everybody is starting. But yeah, I have the pleasure to have Gleam or Pierre from Cartridge. He's a software developer and also is leading the development at Dojo. And he will be having a session on Dojo, and he will talk about the introduction to the Dojo stack, and we'll see quite a lot of exciting things. So just let's wait for 1 more minute until everybody is tuning in and joining in, and then we can kickstart this session. Just as a recap, today marks the second day of this hackathon. Yesterday we had the kickoff ceremony, and it was quite exciting, where we presented all the tracks and we talked a little bit about the hackathon. And then we had yesterday our first workshop, which was getting started with Starknet, which was presented by David Barreto from the Starknet Foundation. You have all the video links and registrations for these in the Discord channel and also on the Biddlebox YouTube channel. So make sure if you missed some of them, check them out. Okay, I think we're ready to start. So without further ado, I would like to introduce Glim, aka Pierre, from Cartridge. He's been an OG in the Dojo development, and I'm looking forward to this session and to the introduction to the Dojo stack. Glim, you can take the floor.
Hi guys, thank you very much, Robert, for the introduction. Happy to see you guys around and happy to see what you can hack to this hackathon session. So actually this workshop, we want to try something a bit different and a bit more interactive. So I will start presenting you the stack, but not on how things work very deeply, but at least giving you an understanding of how it works. We have shared with Robert some links on the Discord track channel. So feel free to check them, and I can put more at the end of this call. So yeah, the idea is in 45 minutes, giving you an idea of how Dojo is architectured and what do you need to know to actually dive into it. And then in the second part of it, we will just go directly into code, examples, showing you how to use the stack. And like this, if you have any question, and if we have time for question, it will be a good, with great pleasure. But if we don't, we will be with Cartridge guys on the Discord. So don't hesitate if you have any questions or anything that isn't clear. Robert, so we can start, right? Or you wanted to add something on your end? All good?
Yeah, no, perfect. All good. For any questions, feel free to drop them either in YouTube or Zoom, and I will try to answer them as best as possible.
All right, so just started the whiteboard. So people should have access to it, or only you, Robert? Because I just see you, so I don't know if people has access to it. Let me know.
Let's check. I
Because
think
I
we
know.
can see it. Yeah, we
Okay, people
can
can see. Yeah,
see.
this is the most important thing. Yeah, people can see. Okay. So just to give you an idea of how it works. So do you guys agree? So when you work with Starknet, you have a smart contract, okay? This smart contract here is the one you are interacting with. So when you send transactions to a smart contract, you are actually sending some instructions and you're calling a functions to actually execute some code. And this code will change something in the smart contract that we call the storage, right? So when you change the storage, this is what you have on chain and what you actually modify when you are sending transactions. And in the way Dojo works, it's still like a contract that you will change the storage of, but you will not change directly the storage you interact with. So let me just introduce you in Dojo. We have a specific contract, what we call the world, okay? So this contract here is the only contract that is supposed to have some state in Dojo. So every time you want to read and write data, you will actually do this on the world contract. So how it works? It works in the following way, where you can write different contracts into the Dojo, what we call Dojo contracts, and those contracts will be the one receiving the transactions. Okay, so you can send transactions exactly as you do on a regular Starknet contract. The only slight difference is like when you write code interacting with the world of Dojo, the storage will actually be modified on into the world, right? So every time you send a transaction, you interact with the world using those contracts here. So as you can see, it's still like a contract you will interact with, but it will be a different architecture from what you already do in a basic Starknet contract. Does it make sense? So this is the first important consideration you might have in mind because you need this to understand where the data are actually coming from. So when you work with Dojo, Dojo actually has a core library, and this core library will take care of deploying the world for you, and we will see this in after this theoretical introduction, right? And the idea is you don't have to care about it, and you just write your logic into those contracts we have here. So this is where you will write the code that will receive the transaction. Then you can make read data from the world, write data into the world, but all the data will be here. So what is the first important thing to know about that is like in the Dojo stack, you already have an indexer that is here to actually serve the data to your client application. And this indexers, which names is Tori, but we will get after that into the details, is the one that will actually monitor what are the events that has been emitted by the world. So every time you will set data into the world, events will be emitted, and those events will be caught up by Tori. And Tori is the one that will serve your application. Okay. So in the case of Dojo, when we talk about application, it's the front end of your game, or it can be something else. But the idea is that the app into Dojo is most frequently a game, but it can be anything else. But in this case, we're in the gaming track. So let me just introduce you with the gaming terms. So the architecture of Dojo and how it works comparison to regular smart contracts. Okay. So this is how you will have the flow of the execution going through. You send a transaction executed like by a contract, what we call Dojo contract, but it's a regular Starknet contract. We will see this in a minute. And then the data are sent to the world, and the world itself emits some events that are caught up by Tori, and Tori serves this to the application. And we will go in detail about the different interfaces that are available. So now the idea is in Dojo, you have a small abstraction, a very thin layer of abstraction of how do you define data, okay? So let me just go into a first example of how does it works. Let me check if I can get back the control on the whiteboard. I just lost him. Can you still see the whiteboard, Warbird? Sorry for that.
I can, yes.
Okay, now I have now the control game. Thank you. So the idea is how do you define data? So if we go into a regular Starknet contract, what do? You have this struct storage, right? So when you have a struct storage, how do you define data? You say, okay, I have a member that is A, and this member will be of type felt 252, for instance, all right? And then I can have a data B, and then this will be a U32, and so on. So this is how you define storage into a regular Starknet contract. The thing is, if you need to modify this, or if you want to have several kind of data in the same storage, you just have to define them like beforehand, right? In the case of Dojo, there is a more flexible way to how you can define data. And what we try to follow for the guys that are familiar with gaming concepts, we're trying to follow this ECS pattern, even if there is slight modification. But the idea is with the entity component system pattern, we are trying to add those dynamic data that you can add into Dojo. So you can see Dojo at some point also almost like a little database that you can use to store and retrieve your data. Let me show you how it works. So in Dojo, what we define is what we call models. Okay, so when you define a model, it's super simple. It's just a struct. So let's say I have my model one here, and then I define my fields here, exactly like a regular, a very regular Starknet struct, Kero structure. Okay, so we have the struct here, and this structure will be understood by Dojo. The only thing you have to add is like a little a macro here when you say, okay, this is a Dojo model. And then I will show you code. So I just give you the intuition here. So when you define this as a Dojo model, Dojo will generate a bit of code around it. And the code generated will allow Dojo to manipulate this model. Okay. So when you store a model into Dojo, you need to define two kind of fields, okay? I think you guys are familiar with the events into Starknet. When you have an event into Starknet, we always have this, yeah, I think the whiteboard is, sorry, check. Yeah, I'm sorry, Robert. Just having some stuck here. My bad, guys. Okay. So what we have when we have a Dojo event, a Starknet event, we define some keys, right? So we will have some fields, and this field will be a key. So this is exactly the same concept that is in Dojo model. So when you define a Dojo model, you define data. So data that can have some fields, but you need at least one key. And this key will allows you to actually retrieve the data and know how the data is actually stored into the database, right? So let's say I have a model and the model has only two fields. One is A being a U32, which is a key, and B, it's a value, which is a field, right? So every time you want to register this model and you want to write data, you will need to give the key. So let's say I just give the key one, it means every time I will write this model, I will write the model using the key one to actually locate the data into the storage, all right? So this is why in Dojo you need to know the keys because the keys allows you to actually retrieve the data. The keys are actually not stored into Dojo. So if we go into the Dojo model, the one here is used to produce a hash, right? And this hash, what is here? So this, we hash this with some details, but when we hash this gives the storage location, right? And the storage location of this model, then we will find here the data B. All right. So if I write the model with a key equal to 1, this will be a specific storage location. If I write this data with a key equal to 2, it will be a different storage location. So this is how Dojo is actually making a database under the hood where you can store data based on the keys to index them. All right. So to complement this, this is interesting to know that in Dojo, when you store a model, you can use multiple keys. So we can have another model here, and this model may have A, which is a U32, but then I may have A1, which is once again a key. So I can also make a key here. So I will do another key here, and this key will be A1, and this one, let's say it will be a U8, right? So when I have this, I still need to have one data field. So in Dojo, you need at least one key and at least one data field into a model. But then when the storage location will be computed, the two keys will be used to compute the storage location, okay? So here we will have the storage location when we will hash those data, okay? And this is how Dojo is actually working. Using the keys, hashing them together, this is how you define where your data are actually stored. And then at the storage location, you will find all the fields of the struct that are not keys. So here, the important thing to keep in mind is in the terminology of Dojo, those are keys. And what we hash and we assume to be the storage location, just before the storage location, what we hash is what we call the entity ID or the entity hash, but usually an entity ID. So as you guys know, hashes are only one-way computation. So it means from the two keys, we can have the hash, but from the hash, we cannot have the two keys. So this is why Dojo allows you to query the data in two ways. Or you can give the different keys that you have when you query data, and then Dojo will hash them and then will compute the storage location. Or you can give directly the hash, what we call the entity ID, and then this one will be directly mapped to the storage location. All right. So it means when you design your game, you can choose depending on where you are in the game. I just want to keep some reference, for instance, to an entity ID. That will be better to keep 5 keys, for instance, because depending on the models, you may have a bigger amount of keys, right? So this is something important in the design of Dojo that you need to be aware of because you need actually to understand this to design how the models will be organized. Okay. So this is what I want to show you guys now at least because you need to know that to I would say to work with Dojo. So I don't know if there is some questions at this point, Robert. I don't have the different channels monitored.
For now, there's no questions, but if the audience have any questions, feel free to drop them and we'll address them. Thank you.
Perfect. Thank you, Robert. So yeah, so this is the important thing to understand about Dojo. So the models are how you actually define data, and you can use any struct of Kero. The only limitation is you cannot have a model inside a model. So you just have to define different structs if you want to use them into models. This is supported, but you cannot have models into models. So when you have a model that is actually written, let me show you what happens into Dojo and with story. And like this, right after this, we will see what happens directly writing some code. Okay. So let's say I have my model here, my model one. Okay. And I write data into it. So when I write data, I will be into a Dojo contract. So I am in a Dojo contract. And let's say I just write this data into the world. Okay. So this is like the abstraction I just showed you before. When I write data into the world will emit an event, as I mentioned to you, for Tori, and this event will say, okay, the model one has been set. This is the list of keys that has been used, and this is the list of values that has been set. All right. So the world takes care of publishing this event for you. And then Tori will actually get those information. Tori will store this into a SQL database, which is managed by Tori directly. Okay, take. Let me just show this again. Take. So it will just make a SQL database which is inside Tori. You don't have to spin up yourself. And then you can query Tori to say, hey, what happened into the world? So when a model is set, the way you can interact with Story for now, you have GraphQL interface, you have gRPC interface, and now we had it also a SQL interface. The SQL interface is still something that is a work in progress, but this is the three interfaces you can use to actually query data from Tori. And when you query data from Tori, you have two ways doing it. You can send queries or you can subscribe to updates. So if you subscribe to updates, then you will have Tori notifying your application every time a new model has been set. Okay. So now the key point that I want to mention is how do you query data? And this is what we will see right after in the code. And we can talk about this more in details if you're struggling with it. But the idea is to query data. Do you remember when we do a model, we actually define keys? And those keys, when they are hashed, they're actually representing what we call the entity ID. Do you remember that? So the idea is those are the two principal way you can actually query Tori, right? So when you query Tori, you can say, hey, Tori, I want you to tell me what has changed, and you can give keys to filter. So let's say I say, hey, you know what, Tori, I want you to tell me what has changed for any model. Let me just remove this, check. So in this case, we have a key A. So do you remember we have like the first key was A and the second key was A1, for instance? Okay, so the just the whiteboard has some issues, Robert. So sometimes it's just like disconnect. So sorry for that.
Maybe in the meanwhile, we have a question until that comes
Yeah, yeah,
up.
go ahead. Go ahead.
There's a question regarding, can you give us a use case of using many keys for one model?
A use case for using many keys in models. So let's say you have a game where you have, so let's say your chess game. When you have a chess game, you will start a game with someone. Then in this case, you might have a game ID, right? So the game ID represents the game where only the two players are in. But also, you may want to be able to query the data for a player in this game. So if you want to do this, you will have one key, for instance, for with the game ID, and you will have a second key with the player ID. So doing this, you are able to organize how the models are stored and how you can query them from the Tor interfaces. So this is one of the easiest example we have with a game and players, and you just have those two references. Is that okay? Tick. Okay, so let's say now we have, so as you remember, yeah, no, it's a bit stuck. We'll just see if I can, but yeah. So we have a model with key A and key A1, for instance. So then you can ask Tori, okay, I want everything that has changed with a key A equal to 1 and a key A2 equal to 2, for instance. So let's get to this game ID and player ID example. If I have my game ID here and my player ID here, I can just use the address of the player and the game ID, and I can query only the data related to those keys. And then Tori will just get the data back just on those data specifically. And sometimes, as we mentioned, we may don't have a direct reference to all the keys. So let's say we have a model with A1, A2, A3, but we may only have access to the hash, which is the entity ID, right? So with this in mind, you may use the entity ID to query Tori instead of using the actual keys, right? So this is how you have to get your mind set when you work with Dojo. The keys allows you to store the data and organize the data in a specific fashion, and then you use those keys to actually query data from Tori. There is more, but I think for now it's enough to give you an understanding of how it works and the important point of designing the models with the keys and then working with them. So if there is no question, I will jump to the code part.
All
You tell me.
good on our end.
All good? Sounds good. Okay, so
Right.
with the links shared with Robert, you have this on the Discord. So this is the Dojo introduction and the book where you can find some documentation around it. So I would recommend to go into the Dojo 101 tutorial first, and then it gives you an idea of how it works. Now, what I want to show you guys is a direct application of the different things that I mentioned to you, which are just the core of Dojo and how this is reflected for you as a developer. Okay. So let's go into a repository. So I will do it again just to show you guys. So we will just clone the starter repo. Okay, the Dojo starter repo, which is also in the links. It's a simple project. We are working on proposing a new Dojo starter, which is a bit more complex, but giving different branches for the different stages of the developments. So this is something that will be easier for you to dive in. But for now, this is what we have available. So when we talk about Dojo, Dojo is a framework that actually has different tools. All right. So when we work with Dojo, you can install it with Dojo app. This is in the documentation, or you can use the ISDF. I think you guys know ISDF. So everything is in the getting starting section, and then you can install it. But the idea is once you install Dojo, you will have different tools, right? You will have Sozo, which is responsible for compilation. So currently, you cannot use Scarb to compile your Cairo project with Dojo. You have to use Sozo, but Sozo is using Scarb. Then we have Katana. Katana is a sequencer. So as you guys know, when you develop with Dojo, with Starknet, you need somewhere to deploy something to test it. So in the case of Dojo, there is a dedicated sequencer that can be used as a testnet, which is Katana. And then we have Tori. Tori being the indexer that I talked earlier. All right. So if I start the project and I am into the project, I think I have the cursor here. So do you remember, guys, I talked about models, right? So what you can see here are the models. So when I define a model, this is a macro you have to use. And now you understand why there is keys and when there is no key, right? We have a key, at least one. It can be several, and you have data. And then I will show you something that we also see earlier. Is like you see here, we are using an array of direction, for instance. The only requirement for something to be into a model is to derive this introspect trait. Everything is in the doc, but I just give you I would say the important information here, and then you can consult it. And then, do you remember we talked about having contracts interacting with the world? And this is what we have here. In the Dojo vocabulary, when we do a Dojo contracts, a function is called a system if we take off the ECS pattern we have seen. And a system is just a simple Cairo function that will actually be called on the contract. But as you remember, when we are actually interacting with the world, we are not storing data into this contract. The data is stored in the world, which allows Tori to only monitor one contract. Okay. So let's just dissect what happens in a function when we are here. When we are into a function, the first thing we need is a reference to the world. Okay, so this is something that has been written here as a utility function. But the idea is when we work with the world, we have this concept of namespaces, and I think it's I don't need to go too much in detail for that, but namespaces are just where do you store models? So I can have my model, which is called moves, and this model can be stored in namespace one, namespace two, namespace three. It will just change the storage location, right? It's just a way to reuse models. But in a simple project, you will only have one namespace and you don't have to care much about it, okay? So once you have your world, then here we are just getting the caller address. And then, for instance, here we are just reading from the world. So as you can see, reading from the world is a very simple operation. You can read a model. And as you guys remember, you have to give the keys, because if you don't give the keys, then Dojo doesn't know where to read into the storage, right? So here we are using the keys, but there is different functions available where you can actually use, for instance, the hashed keys to get the data. So here we get the position, we set a new position, and then rewrite the position. So as you can see, read and write are very self-explanatory. And once you have done this, what happens under the hood, you just send a call to the world and the data will be stored into the world. Okay. So this is what happens here. So how do I work with that? So the simple answer is using Sozo. So Sozo, you have a function that is let me just okay, yeah. Tempe Dojo starter. So we have a Sozo build function. The Sozo build function will just build your code and adding the Dojo layer that needs to be added, right? And once we have the code built, what we have to do is actually sending this code into a sequencer, right? I mean, a Dojo network when you want to test it. So you can test it for now. Starknet Foundry is not supported yet. So you can test Dojo code as you do usually with a Kero test runner. So it's just a test, and then you can spawn a test world when you define which model you want to define into the world, which contract, and then you write simple code just to write your test, right? But when you want to interact with it into a test net, you can directly use Katana, right? So here we have built the code, and then I will start Katana. So to start a Katana, I just use a dash dash dev. And when you start Katana, you already have pre-deployed accounts that are actually registered into Sozo. So when you go into a Dojo code, you have this dojo underscore dev file. So you have one configuration file for profile. And the idea is the Dojo Dev is the default one. And here, as you can see, you have different information from the will, the famous default namespace that for now can stay one namespace. And then we have just few configurations, which can be the RPC, the different addresses you want to use when you work with the testnet. And you can define one file for each profile. So if you guys are aware of that, you can have into Scarp different profiles. So I can have my production profiles here, and then I can just have to define it in Scarp, and then I can just work with it. But everything is described into the Dojo documentation, but just to give you an idea why we have some data and how we can configure files depending on the config of the profile you want to use. So here, everything is configured for localhost Katana with one of the accounts of Katana, right? So then what I will do is I will just migrate the code, right? So I will do a Sozo migrate, and Sozo migrate is actually checking if there is already a world into the remote testnet, which is not the case for now. And then it deploys the word for you, declare everything, all the classes, all the contracts, and deploy everything. So you don't have to manage this by yourself. And once this is over, just wait the initialization of the contracts. Here we don't care about IPFS, it's just a demonstration. And now we have a world address. So as you guys remember, we have the world being deployed. Then we have all the contracts around. In this case, we only have one contract with these actions contracts. And then we will try to see what happens in this world. So if you guys remember, we have the Tori, which is an indexer, and we will just give the world address of this to Tori, right? And then Tori starts indexing. Tori by default works in memory, but you can start also Tori using a database directory, and then you will store the data into this database. Like this, you can introspect the database with any program that you want. But for now, let's just go into this. So now we have Tori pulling the blocks and waiting for data. So let's just send a transaction. When we send a transaction, you guys may be familiar with Starknet, with SNCast, or other framework you can use, or SDK. With Sozo, you can directly do what we call a Sozo execute. With a Sozo execute, Sozo knows the context of your Dojo world and the different contracts. So in this case, do you guys remember we have a contract and this contract is named actions, right? So if I want to call this contract, I have two things to do. I can do a Sozo inspect, and the Sozo inspect will show me actually what's in the world. So I can see the world, I can see at which address, and then I can see my namespaces, my different contracts, maybe a bit big for this. And then we have all the models we have declared and the events. I will get to the events right after that. But the idea is you have two ways. You can go here, check your contract and check the address. This is one way. Or you can just use the fact that Sozo has access to the manifest produced by Dojo, and you can do that. You can do Sozo execute, the name of the contract, and then the name of the system. In this case, it's spawn, okay? So I will just hit that. In this case, I don't have any arguments because this self is not something we have to pass. But if I have to pass an argument, I just have to do -c and then I can give it. And now I just execute the transaction. When the transaction is executed, on the Katana side, you will see the transactions going through. It can be any public network. It can be Sepolia or mainnet. And then what we see here is like Tori has reacted to that. So Tori have seen that, okay, there is something that has been said. So if we go back into the spawn function, what do? We are actually writing the position and we are writing the moves models, right? So if I go into Tori, I have a moves being detected, being written, and I have a position. And if you guys remember, when we have a model, we have to set keys, right? So if I go back into models, I have a player key into moves, and I have a player key into position. It means as those two have the same keys, the entity ID will be the same. And this is what we see here. We see a write of the moves model for the entity 043. And same thing for the position 043. Okay. So this is a demonstration end to end, how it works from when you compile the code, when you write the code into the system, the world is being deployed, you send data to the world, just writing your contract, and then Tori catches all the events happening into the world, which includes all the data you might want to set, right? So let's just get an example of the move. So we have a move function, and what we move, we actually have to give a direction, right? A direction is just an enumeration that is left, right, up, down. So when we are here, I can send a transaction doing, okay, this time I want to move, and then I will give one when enumeration of this kind in Kero is 0, 1, 2, 3, right? So when I do such here, I will have a transaction. And if I get back to Tori, I actually have the different things being updated. And since I am the same people, the same account calling, the entity ID will be the same. If I change account, the entity ID will be different. Why? Because the key that is used into the models is the player address, and in this case, the get caller address will be different. All right. So this is a basic demonstration of how do you have those data being emitted and coded by Tori. And now the last piece of that is how do you get those data from an application perspective? And here you have two ways, I would say two ways, it depends. First, it depends where you are working. You can have the Unity SDK, you have the Dojo SDK, or you can directly use Dojo.js also. When I say Dojo SDK, is Dojo.js. So to give you an example of that, there is a repository that I will send into the channel where one guy is actually Martian Grid is working on an on-chain dashboard just to showcase all the different use case of Dojo using Dojo.js. So I will give you this link, guys. And also something that for you that are a bit more interested to dive into how does it works low level when you use Tori. The idea is the Tori client is embedded into what we call Dojo.c, which might be renamed, but Dojo.c contains a Tori client in a WASM that can be used in different places or directly in Unities using the C bindings. And here you have a playground. And this playground is a simple one-page web page where you can just interact with gRPC and Tori, and then you can just build your own queries. So just to give you an idea, when we work from JavaScript trying to query Tori, we have the different configurations, and then we have the queries, get entities. And here you will find in the different places in the book what does this means and how do you query. And if you guys remember, we have this keys being involved, right? So here, for instance, we have a key close, and here we have the different keys, and we can say, okay, I want something that have at least one key, and it can be more keys or different things like this. So I really encourage you, if you are new to Dojo, to try using this first layer to interact with Story. Or if you prefer, you can just go directly with Dojo.js, and Dojo.js is just an abstraction on top of those queries, right? So this is how it works. I think for the time we have, it might be just to dive into the more into the front end. I just want to complement, but first, do we have some question, Robert?
No, so far so good. All questions are answered. We're doing good.
Okay. So what do you have accessible into your Caro code to actually work? You have the models. So as you have seen, the models are the way you define data, and every time you will set data into a model, it will replace the data that is actually on chain already, right? So if I use spawn here, so let's just go into an example and let's use story with a database. So DB1, 2, and then we will just say DB there, and then we'll TMP DB2. So we'll just start Tori with that, and then we will just edit this configuration. Where is that? Take. Can we just edit the connection? Yes. So we have DB2 test, good. So this is the database that is produced by Tori, right? And as you can see here, we, for instance, have all it's readable, Robert, I think, yes? Or you need more?
It looks good. It looks good.
Okay. So here, this is how Tori works and the database that is produced by Tori. So here you can see the different models that we have defined into our code, right? And every time data is set into a specific model, a new table will be created. So let's just get back into our code and let's just execute some transactions here. So if we execute the transactions, we should have now, like, let me just get back on it. Okay, sorry. Okay, sorry for that. I'm just not seeing. Okay, so this one is not the connection I need. Where is it? To just remove from here. Okay, I just don't know exactly how to get out of it. Okay, so here should be the good one. And here, do we have here? So here, as you can see, we have different tables, and the different tables are one for each model. So if I go, for instance, to the model moves that we have seen has been set, you can find here the same entity ID that has been emitted by Tori. And then we have all the different fields with the different values. But every time I will change something, Tori will actually rewrite something on place. So it means Tori will always give you the latest state that you have on chain, right? So if we go into position, for instance, we know at this moment where the player here is with the vec here with the different positions. And if I moved it again, then the position will change, right? But Tori will actually keep always the latest state. So you see here, it was moved back to 19 just for the move I made. So if you need to publish something that you want to have the event like in Starknet, so sometimes you want your game to actually have a list of events that happens in not only the latest state, you can also do that. And in Tori, we call this historical events. So you can just have events being published, and instead of just keeping the latest state, you can have also Tori remembering everything that happens for this event, right? Let me check here if we have an event somewhere. I don't think we have events for this example. We have move, world emit events, moved. So we have moved, for instance. So moved is an event. So in this case, it's an event. So just to be clear, a model is something that is stored into the storage, and an event, as you can expect, is something that is just emitted and meant to be stored into Tori. and it will never be stored on chain. All right. So once the event is emitted, as you can see here, we still have the latest direction that has been taken by the user. But if I move again, this event will actually be emitted. So now I went down, but as you can see, I don't have the historic here. So this is something you can enable into Tori. So if you are interested in something that is historical, you can also do it. But by default, everything is being like the latest updated. So you can choose the configuration you want. And when we will go into the front end, so the idea is you will just configure the SDK to point to your Tori. So your Tori will be the point of contact, and then you will just have everything being updated automatically. Let me just show you perhaps if we have, yeah. So this is a diagram that recap a bit what we have seen today, where we send transactions to a system which is just a function into a Dojo contract. Then this function is actually setting or reading data from or to the world, and this triggers some events being emitted by the world, and those events will be coded by Tori, and Tori will serve the client. And as we mentioned, we have three interfaces for now. I mean, two widely supported, and the SQL is a bit, I would say, still experimental, is gRPC and GraphQL. So yeah, I think this is without going too much into details for the time we have, I think it's a good overview of how Dojo works. I don't know if we have questions or if there is a specific topic you guys want to check or if everything is clear until this point.
Let's see, no questions neither on YouTube or on
Mhm.
Zoom. I think people are saying everything is going well.
Okay.
So yeah.
Sounds good. So for the guys that will work with Dojo, the SDK that has reporting currently is Unity SDK. There is a Dojo JS also SDK. So this is, I would say, the two main entry point to Dojo. But if you are building something different and you may just want to interact with a Tori, then you can use the Dojo.c because Dojo.c, as I mentioned, there is a Tori client in C binding. So you may want to reuse that anywhere, just writing the bindings for a different platform or something. That can also be a good topic. And yeah, I really recommend people building that, just diving into this playground and understanding in those examples, just understanding how you can query the data. But the most important to remember, if you have a central world that is gathering the data, and then when you query the data, which are the models, you use those keys and those entity ID, which is a hash of the keys, to actually tell when you query, what do you want to query? And if we have 2 minutes more, I will just remind you guys about the subscription that you have. So on the GraphQL side and the gRPC side, you have subscriptions available. And those subscription, you can define on what do you want to subscribe. So let's say we get back to this chess game when we have models with game ID and player ID. You may choose to subscribe to everything that happens in a game. To do that, you will just make a subscription. You will put the game ID. Variable length here is just saying, I don't care if there is models with more key. I want everything that starts with this key. And doing this, Tori will automatically update your clients every time something changes in this specific game. And in different place of the application, you may want to update the subscription. So the recommendation is you might not need to open new subscription every time you move into your application. You might just want to actually update the subscriptions depending on where you are into your application. And this is something we have seen very useful in the different games that has been shipped currently, where you can actually adjust the data you want to fetch based on your game scene at some point, if I can tell it like this. So yeah, I think it's more or less everything. Sorry for the whiteboard stuff. It was experimental with Warbird, but I think it didn't go that bad, but it might be better the next time.
No, I think it was great. I loved it, honestly. I think it made it more interactive, and I think also the audience liked it. So it was all good. All good.
Nice. Nice, nice.
Okay, so thank you, Glenn, for your great introduction to the Dojo stack. I hope that was insightful for everybody. For support on the gaming track, feel free to join the Beetlebox Discord channel. You'll have access if you sign up for the hackathon on the platform, and we'll be there to assist you with any questions, support, or technical questions you have on Dojo. Please join. Everybody's there. And yeah, a special thanks to Cartridge for leading this track. Don't forget about the two special bounties from them, which are deploying with slots and on board with the Cartridge controller. You can basically maximize your bounty price with this. That's it for
Oh,
this session. Yeah, yeah,
sorry, that's a good
please.
point. I didn't know that was into the track too, but yeah, no, good point mentioning slot and controller. Thank you.
Yes, those are really good things. Make sure to check them out as well. And if you're developing a game, you could potentially apply for the three challenges, so to say. That's it for this session. Up next, in just a few minutes, I think we'll start in 15 minutes. We have Building Effective AI Agents with Simple Composable Patterns by Kirill from Nethermind. Glim, thank you for this session. For the participants, thank you for tuning in. And I'll see you in just a bit. Have a great one.
Have a good
Bye.
hacking. See you guys. Thank you, Robert.